Okay, so this video is going to show you how to determine the limiting reagent with a couple of different types of problems. So the first thing that you're going to need to have for this first one is with the NaOH and H2SO4 is you need to know what the balanced equation is. So it'll be sodium hydroxide plus H2SO4. That's going to make sodium sulfate Na2SO4 plus H2O. Balance the equation. We need a 2 here, then 2 and 2 is 4, and a 2 there. Okay, that's the balanced equation. Now, there's a couple different ways you could do it, but I think I would just look at it and say, I'm going to guess that NaOH is a limiting reagent. I could be wrong. All right, so until I'm not really sure, so I'm just going to start with that. So it doesn't really matter. So anyway, which one you start with? So 45 milliliters of NaOH. I'm going to get that to moles by using the molarity. So 3.0 moles of NaOH for every 1,000 milliliters. Now what I'm going to do is I'm just going to keep on going with that, and I'm going to see how many moles of H2SO4 I would need. And so the balanced equation says for every 2 moles of NaOH, I would need 1 mole of H2SO4. I'm using the mole ratios from the balanced equation. And when I do that math, that means to react of all the NaOH, I would need 0.06, roughly 8, and this should be 1 mole here, 0.068 moles of H2SO4. Now, all you got to do is see, well, how many moles of H2SO4 do you really have? So you can start with 25 milliliters of the H2SO4, and you can use the molarity to get to moles. So you've got 5.0 moles of H2SO4 for every 1,000 milliliters. And so if you do that math, you end up getting 0.12 or roughly 0.13 moles of H2SO4. Now, this first thing that we did shows that if all the NaOH reacts, you're going to use up 0.068 moles of H2SO4. But you have 0.13 available. So the limiting reagent then has to be the NaOH. Because if all of it gets used up, you're only going to use 0.068 moles of H2SO4. You have 0.13 available, so the NaOH is a limiting reagent. Okay, let's try another one. So this one we have silver nitrate plus copper metal. So that's going to make copper 2 nitrate plus silver. Balance the equation. Put a 2 there and a 2 there. All right, so we've got 23 milliliters of the silver nitrate, and it's 0.89 molar, and we got 2.8 grams of copper. Well, there's a couple different ways you could approach this to see which one's a limiting reagent, but I'd probably start it like this and say, well, I'm going to start with the silver nitrate. So 23 milliliters of silver nitrate, and what I'm going to do is just see how many grams that would take of copper to react. So anyway, then I'm going to use the molarity, 0.89 moles of that over 1,000 milliliters. That's the silver nitrate. Okay. And then what I'm going to do is do the mole ratio. So 2 moles of silver nitrate, I'm getting that from the balanced equation. 2 here, to 1 there, to 1 mole of copper. Now, I could take this grams and change it to moles and see how many moles I got, or I could just keep on going here and use the molar mass of copper. 1 mole of copper equals about 64 grams of copper. Now, if I do this math right here, that's going to tell me how many grams of copper that would react with all the silver nitrate. And so when I do the math, I get that the answer is 0.65 grams of copper. Now, you have 2.8 available, you're only going to use 0.65 if all the silver nitrate reacts. Therefore, the silver nitrate is the limiting reagent. Now, if you were to do this problem and you got, like, let's say you got like 3.5 grams of copper was the answer, then you would look and say, well, I need 3.5, but I only have 2.8. Then the copper would have been the limiting reagent. So there's a couple different ways you could approach it, but I think this, the way I showed you, works the best.